Continuing with the second of 3 videos on the nacelle, we have our guide curves created. That means we need to create the cross sections in order to end up with some multi-section surfaces. So now we're working on the front cross section, which is on the plane on the back side of the leading edge. If you remember from earlier, we have the 2 planes in the front. This is on the aft of those 2. And you'll see from the front view drawing that this section appears to be fairly close to an ellipse, fairly close to elliptical. So we'll make it as such. And we're looking at the outside of that black circle, the inner circle, outside of the inner circle, or ellipse. And the drawing isn't necessarily all that accurate, so we're going to call that good. And now the trailing edge cross section. We'll just go through the 4 points that we get from intersecting 3D elements of the guide curves. Now, to get the unique shape of the nacelle, we're going to add a plane through the point where the bottom contour is lowest. And we're going to assume that the widest part of the bottom of the nacelle, where you can see it where it balloons out from what would be an elliptical cross section, we're going to assume that that occurs at the point where the bottom contour is lowest. And we can just eyeball that. Actually, we'll make it tangent. You could create a point that's tangent to the bottom, but this is fine. And now we will create that cross section. We'll start with an ellipse, and then we'll add a spline to the bottom half to get that shape. Now, I'm going to show you this method first, although we'll see that it ends up not working. So you might not want to follow this. The method that will work is creating a construction element of this ellipse that I just created, and then create a spline that goes all the way around. Constrain the top half of the spline to the ellipse as best you can by creating lots of control points and making them coincident with the ellipse. But on the bottom half, you just make the point that is in the middle coincident with that guideline, and allow the other ones to bow out and try and move them around to get the best shape you can. And that'll be the method that ends up working. For some reason, this one gives errors when we create the multi-section surface. But here, so we have the, you'll see that method later in the video. Here we have top half is an ellipse, the bottom half is a spline, tangent on the left and right sides, coincident through the bottom guideline. We're just trying to let this follow the approximate shape of the nacelle. And obviously not normal to the plane here. There we go. And now to create the multi-section surface. Let's name things first. So this surface works, but when we have these guidelines, it errors out. You can go through a couple debugging tips here where we'll add the guidelines one at a time to see if there's a problem with the guideline. Here the top is working, but when I add the bottom or the side, it errors out. But to make sure that it's, to see if it's the two guides that are causing the problem or whether those other two are just broken, we can add one of the first guidelines first. See, that works. So it wasn't necessarily the problem. Then we'll add the top, which was working before. Or the port side, which wasn't. But so it seems that the error is using multiple guidelines rather than there being a problem with the guideline. And so here I'm omitting that middle sketch, and the guidelines work fine. So the problem doesn't seem to be with the guideline, it seems to be with that sketch in the middle. And here, to make sure it's a closed contour, I'm going to use the fill command on it. There was that discontinuous point, but it still created the fill, so that should mean that's closed all the way. And I thought perhaps there could have been just a gap where the spline wasn't coincident to the correct part of the ellipse. We'll go back here, and it's possible that the spline was just created incorrectly the first time. For example, if these points weren't coincident, if the endpoints were coincident, or rather some point right next to it. So you could go through this procedure again, just add a new spline. But again, I'm saying that this isn't going to fix it, because I happen to know this would just kind of be your possible standard debugging procedure. Add tangencies and make them parallel. I added one on the bottom here, make that horizontal. Wouldn't give us the parallelism option, so we'll have to do an angle 180. Make it coincident to the guideline. And I didn't worry about comparing it to the drawing so much because I just want to see if it works, which it doesn't. So again, back into the sketch, and like I said the first time, just create an ellipse through all the guidelines, leave it as a construction object, then create a spline with a lot of guide or control points, and then you can make it a closed spline. I'm adding a tangency to all the points along the top, so that I can make it tangent to the ellipse to make it more accurate. we'll just move these bottom points around. You know, this is a fairly good approximation for the top because I move the points and it doesn't move too much. So we'll go with that. And there we go. It looks like it worked. No red.